So don't say anything too crazy off color. Make sure you're kind of following along. If you can, put any corrections or additional statements in like a different color or pen not pencil or pencil not pen or something different if you can. If you're like, I have my one pen, that's all I've got, then that's your one pen, that's all you've got. Okay? There are 12 possible points for the performance task. Letter A, construct a Venn diagram of the probabilities from the teacher's survey. Based on the probabilities, are the events, course grade was a C, and did at least 30 minutes of homework, independent, explain your answer. 3 points max. 1 point for drawing and labeling the Venn diagram correctly, but if you look up here, if I can find my mouse, this was all you had to do. A grade of C and did the 30 minutes of homework. The overlap of that is 0.07, which means that the rest of the got a grade of C was 0.13 because 0.20 or 20% got a C. And then did the homework, which was 70% of the students, right? It's 0.63 in the outer circle and 0.07 still in the overlap, which means only 7% of the students both got a C and did the homework. If you multiply these, the 0.7 times the 0.2, you get 0.14. That doesn't match up. So they are dependent in this case. Which makes sense. If you do the homework, your grade should actually be higher. Which is why the higher probability, and like the highest one, I think, on the whole table was the people that did the homework and had an A. The people that weren't doing the homework and had A's was very low. And then aside from that, yeah. So 1 point for having the correct Venn diagram with the labels. Oh, and then, what is it? Yeah. You should have out here as well, what is that one? Oh, 0.17, which would be neither of these things. Okay? You should have the rest. Everything should add up to 100%. So for your Venn diagram, within the grade of C was 20%, within the homework was 70%. If you add the 70% plus the 0.13, that's 83%. But you need to have representation of 100%, so there'd be 17% outside it. You could potentially be getting credit for this if you had the full Venn diagram of all the grades, because then all of that stuff would be represented. But the full Venn diagram of the grades would be a circle for A, a circle for B, and a circle for C that had 0 overlap, and then a single circle for did the homework, and you'd have that proportioned out. So it'd be a big mess if you tried to have all of them there on the Venn diagram. 1 point for concluding that they are dependent, and 1 point for using the probabilities to explain why. Okay, so if you just said these are dependent, you can get a point from that. If you had the math and prove that they were dependent, then that's another point there, and then 1 point for the correct on the Venn diagram. So even if you miss like part of the Venn diagram, it's like a 0 or a 1. You got it or you didn't. Scoring note, only one of the explanations for independence is necessary in order for the students to get the point. If a student incorrectly labels the Venn diagram but uses the values to correctly find the probabilities, should not get the first point but still can get the remaining 2. Okay, so if you didn't have the Venn diagram right, but you had the rest of the stuff right, you can still get 2 out of the 3 points on this one.
So can we just put like +2 to the front?
Yeah, that's fine. Or 2 out of 3 there or whatever. Yeah. Letter B. The table below shows some of the relative frequencies, and then there was 1 and 2 underneath the table that are all going to come together. There's 3 points possible on this. Why is this going out of order? That's weird. The small letter I here, or part 1 of B, if a student's course grade was B, what is the probability that a randomly selected student did at least 30 minutes of homework a night? That means you're selecting from your B. So this should have been 0.21 over 0.30. Okay, there was 0.30 total that got a B, and 0.21 of those were doing the homework at night. So that's 0.21 over 0.30, which is 0.70. So that's like 70%. Okay.
If we just put 0.70, is that fine too?
That's probably okay, but you should show the work.
Well, if you show the work, then.
You get 0.7, yeah. Like the work is just 0.21 over 0.30 equals 0.70. So yeah. And then part 2 here, are the events did at least 30 minutes of homework and course grade is a B independent?
So if you got that right, it's plus 3, right?
No, that's 1 point.
Okay.
Okay. Part 2 on this one, these are independent because 0.3 times 0.7 is equal to 0.21 and 0.21 is the combined probability. If you go back up and look at the table, 70% of the people did 30 minutes of homework. That is the probability of doing the 30 minutes of homework. And then 0.3 was got a B. So we multiply those together. The product of this, if that's the same as this combined probability, these are independent. It is the same. So these are independent. And you should have some words on that because it does say explain your answer. Yeah, there's 1 point for calculating the probability of doing at least 30 minutes of homework given that the student's grade was a B. So you having this 0.21 divided by 0.30 is 1 point. There's 1 point for concluding that they are independent and 1 point for using probabilities to explain why the events are independent. Okay, because the products match up and whatever.
So for part I and part II, if you did both of those right, how many total points would you get?
If you did both of them right and you use the probabilities to explain, you should get all 3 points. If you didn't use the probabilities to explain why they are independent, then it's not good. Now notice that they didn't fill out the table and they didn't count that as any points. So you were supposed to fill out that table just so you could answer these questions and answer some of the questions later on. So over here in this A square should be 0.42. In this C square should be what? 0.13?
Yes.
And down here should be 0.3. Okay. Letter C. Based on the results from part A and B, what should the teacher conclude about the association between a student's course grade and whether or not the student did at least 30 minutes of homework? For the students who had a course grade of C or an A, there's a level of dependence there. Okay? So, bless you, maybe? The proportion of students who had a course grade of C and did 30 minutes of homework, 0.07, is half the proportion if they were independent. The one that's B is exactly the same, and the one that's A, would be different if you did that, okay? So, you should get 1 point for indicating that there is a dependency on the 30 minutes of homework, or there's an association there between doing the homework and having a C. Particularly that it's lower. Okay, if you're doing the homework, the probability of you getting the C is lower. But there's no association between the 30 minutes of homework and getting a B. So it's right where it should be, in other words. 70% of the people in the class did the homework, and 70% of the people that got B's were doing the homework. So it just matches up. And 1 point for concluding that not doing the homework seems to affect the lower performing students. Okay, so there's 3 points there. 1 for saying that there's an association between the 30 minutes of homework and getting a C. 1 point for there's no association between the not doing the homework or whatever and getting a B. And 1 point for saying that doing the homework seems to affect the lower performing students, the ones with the C's. If you incorrectly calculate the probabilities on the other ones, but still come to this same conclusion, you can still get points for this one, which is always interesting about College Board. If you do a wrong bit of math early on, but you use that and do something else correctly later, you can still get full or partial credit sometimes. Okay, part D. The school's principal is conducting some focus groups and will randomly choose 3 students from math classes. Assume that the 3 students will be chosen from the group of students who answered the survey above. This is the one that I think I had the most questions about. A lot of people weren't really sure what they needed to do. So part I says, what is the probability that all 3 students selected had a course grade of an A and did at least 30 minutes of homework every night? And then part 2 says, suppose you know these probabilities. The probability that 1 student out of 3 had a course grade of A and did at least 30 minutes of homework is 0.4239. The probability that 2 students out of the 3 had a course grade of A and did at least 30 minutes of homework is 0.3069. What is the probability that none of the 3 students selected had a course grade of A and did at least 30 minutes of homework every night? Explain the work leading to your answer. So this one's a little weird. It requires some calculation and it requires some knowledge of percentages. And we haven't really spent a lot of time talking about compound probability, but you have some compound probability here dealing with 3 students. Okay, for part A, the probability that a randomly selected student's course grade is an A and did at least 30 minutes of homework is 0.42. That was the one on the front side that we had to fill in that little square. The probability that all 3 of them had an A and did 30 minutes of homework is 0.42 times 0.42 times 0.42. So you multiply it all 3 across that. So it's 0.074088 is the full thing that they have across it. Okay? Now, armed with that knowledge, there's a couple of different ways that you can attack number 2. We know that whenever you're talking about percentages, you have to have 100%, right? So the probability of all 3 having that A was like 0.07 basically. The probability of one of the 3 having it was 0.42. The probability of 2 of them having it was 0.31, give or take. So we add all of those together and subtract it from 100, and that would get you the last one. Okay? Because everything has to add up to 100%. So if you make it to where it adds up to 100%, that's where we are. All right? The other way that you can do this actually goes back to your box up here. Okay? The probability of them not having an A and not doing the 30 minutes of homework is all of the rest of these from here, except for this box, combined. So if you look at this one, this is 0.42. So everybody else would be 0.58. So you could have taken 0.58 times 0.58 times 0.58, and that would have gotten you the exact same answer of like 0.195112. They didn't say anything about like limiting that, so probably if you went to like 3 decimal places, or you said like 19.5% or something like that, you'd be good on that one, okay? So you get 1 point here for doing part 1 of this correctly. So multiplying the 0.42 times 0.42 times 0.42 and getting an answer there. You get 1 point for a correct explanation of your work in part 2. Like, what did you do? I said that we have to have 100%, and I subtracted all 3 getting A, 2 getting an A, and 1 getting an A. And whatever percent was left is the right answer. Or I went and looked at my table and found the probability of them doing neither of the things and multiplied that out. And you get 1 point for recognizing that everything has to add up to 100%. Okay? So that's either you said on this one everything has to add up to 100%, and that's why you subtracted and got the answer, or you said everything has to equal 100% up on the table, and that's where you come up with the 0.58. So a single point for calculating the probability in part 1, a single point for explaining what's going on in part 2, and a single point for actually calculating it correctly in part 2, if that makes sense. Again, they have a scoring note on this one. If a student arrives at an incorrect value for the probability in part 1, but uses it properly in part 2 and 3, you can get still the second and third point. So if you stopped at like 0.07 or something like that, and you're like, whatever, you could still get the points for 2 and 3 if you use that 0.07 correctly in putting everything together. All right, I'm going to go ahead and hit stop on this video.